I'm Ashley Whipple. I'm a graduate student at the University of Colorado Boulder, where I'm studying for my master's in ecology and evolutionary biology.
For my master's, I'm researching the relationship between predictions of climate change vulnerability of pika and stress within populations at Rocky Mountain National Park and adjacent Indian Peaks Wilderness.
Pikas are a small relative of the rabbit family, about the size of a hamster. In Colorado, they live in high alpine ecosystems, in talus slopes like this one.
Pika are a good indicator of ecosystem health, so if we know the status of pika, we can make predictions about the system as a whole.
Pika are a great animal to study because they're really easy to find. They only live in talus slopes, and they don't migrate or hibernate like many other mountain species do. They're also really easy to detect without seeing an individual. Throughout the summer, pika will collect vegetation and create hay piles like this one here. You can see from this hay pile that it's freshly collected and there's an active pika in the area.
Starting in 2010, the National Park Service collaborated with 3 Western universities to conduct a study they called Pikas in Peril. This study assessed pika's vulnerability to climate change in 8 national parks. I'm particularly interested in Rocky Mountain National Park. This is a map of the mountain region of the park that is good habitat for pika. The bright green color represents a high probability of pika occupying that habitat. Bright blue is medium probability, and dark blue is low probability. Anything below 0.4 is no probability of pika occupancy and is not represented on the map. This is the same map as the previous slide, but now it's the probability of occupancy under modest greenhouse gas emissions. As you can see, there's no green color on the map, just medium and low probabilities of occupancy. By 2100, in this scenario, pika populations will become very fragmented. This is now the probability of occupancy under high greenhouse gas emissions. Through time, the probability of occupancy drops below 0.4, and by 2100, pika are predicted to be extirpated from the park. So what these models are predicting is that in the future, Rocky Mountain National Park will experience higher temperatures, causing habitat suitability and connectivity between populations to decline. I'm predicting pika populations will be facing similar outcomes in the Indian Peaks Wilderness. So we have these predictions, and in some scenarios we believe pika will be extirpated by 2100. But what if we can be ahead of predictions and take actions before extirpation? And what if we find that we can refine these predictions and that they are actually happening slower or faster than what we thought? That's where stress hormone analysis comes in. The release of a stress hormone is a natural process and can sometimes be beneficial to the individual. For example, if an animal is water stressed, stress hormones are released. That animal can then react and move until they find water. It's bad when an animal experiences high and constant levels of stress, which can actually reduce the health of the animal and even lead to death. Well, how do you measure stress? In response to a stressor, vertebrates release glucocorticoid hormones, which can be measured in fecal samples. This summer, I collected feces from 21 sites in the Indian Peaks Wilderness. I will take these samples back to the lab, and this fall, I will measure the amount of stress hormone in each sample using a corticosterone enzyme immunoassay kit. With the support of the Indian Peaks Wilderness Alliance, I'm able to buy 2 kits, which will allow me to analyze up to 200 samples. A great kickstart for my research.
I'm going to continue to collect and analyze samples next summer, and I'll publish my findings in 2019. I'd like to thank you for your support and interest in my research.